Alright, welcome to our very first video for Unit 7. This is actually day 3. We've been taking some notes in class. And so now we're going to do a short video to introduce this third part of our lesson, and it's going to focus on angles in circles. Now, most of this very first part I'm going to show you, you guys are familiar with. There's not a lot to it. And so I'm going to make sure that you guys pause the video and try and draw these diagrams the best you can. So you'll notice that top of my page, I've got our heading here with our title, the lesson, and then I've got this this divider in your page, splitting pretty much the rest of the page into 4 equal pieces. Okay, so you can kind of see that. I'll zoom out a little bit more. You can see almost the full page like that. All right, so you can kind of tell what this should look like. And again, try and draw these circles to the best of your ability. I'm not going to grade you on accuracy, but we definitely don't want to make it look too sloppy so we can't understand what we're actually showing you. Okay, so these 4 sections, this first one is when we have a central angle. So these are all talking about angles in circles. So at any time, if you need to pause to copy any of this down, go ahead. This first one, label it as central. And then this one at the top right, label in. And that's whenever we have an angle inside the circle somewhere else. Notice this is not the center of the circle. I've purposefully drawn these intersecting lines so they are not in the center of the circle. The center of the circle would be somewhere closer to here. Okay? And then these bottom 2 are labeled on and out. In this case, on, the vertex of our angle is on the circle. And I want you to try and draw all of these lines. Notice we actually have a tangent, and then we have these 2 secants forming this angle here. And then another time is when we have 2 secants that intersect outside the circle somewhere. And so the vertex of this angle is outside the circle. So make sure you have your page set up like this. And we're just going to take a few notes about these different ways we could have angles in and around circles. Okay, so let's take a look more specifically at the central part of this. Okay. In a central angle, the measure is equal to the arc measure. Okay? In a central angle, the measure of the angle is equal to the arc measure. So if I called this angle A, B, C, we could say the measure of angle ABC is equal to the measure of arc AC, the corresponding arc. So if this is X, this is also X. All right? And that's when we have a central angle, when the vertex of the angle is the center of the circle. All right. So I want to move over here to this right-hand side. And this is when we have an angle inside the circle where the vertex is in the interior of the circle, but not the center. When the vertex of the angle is in the interior of the circle. Okay, when the vertex of the angle is in the interior of the circle, the angle is the average of the arcs. And I'm going to explain that. There are 2 arcs. Okay, so let's say we were talking about angle 1. Okay, I'm going to number this angle, angle 1. I'm going to give these 4 points some labels. Let's call this X, Y, Z, and W. In this case, okay, we had a formula for our last part for a central angle. We're going to have another formula, but it's a little bit different. In this case, the measure of angle 1, this angle right there, is the average of the intercepted arcs. Okay, we'll talk more about this later on. but it's the average of these arcs. Forgot the word intercepted. Okay? So we can say the measure of angle 1 is the average of these two arcs. And to find the average, remember, you add them and divide by 2. And so instead of saying divided by 2 in a big long fraction, I'm going to use the 1/2. And I'm going to say the measure of arc xy plus the measure of arc wz. I kind of ran out of room there, but you get the idea that this angle measure is half the sum of these two. Okay, so if we said this was 100 degrees and this was 72 degrees, this angle would be half of the sum of 100 plus 72. So we would do 100 plus 72 and get 172, and then we would divide that by 2 to do our half. All right? Now, the vertex of your angle could also be on the circle somewhere, like this example. And when the vertex of the angle is on the circle, okay, underline on, the angle is half of the intercepted arc. And I'm going to highlight part of this for you so you see what I mean. So let's say I was talking about this angle 1. Okay, we have this angle 1. And let's say we call this angle RTS. The intercepted arc here, the arc that connects both sides of the angle, is arc RS. So that arc corresponds to this angle. But because this is not the center, this is a lot more like the previous, but we only have one arc to use, and so this angle is half of the arc. So if we're going to write a formula, we can say the measure of angle 1 equals 1/2 the measure of arc RS. Okay, so we just take half of the arc. We don't have two arcs to add together, we just take half of the one that we're given. Okay, and we're going to look at a lot of different angles here. There are several other angles we could talk about with the vertex still on the circle. Okay, and that brings us to when the vertex of an angle is outside of the circle. Okay, when the vertex of the angle is outside of the circle, or we say in the exterior of the circle, the angle is half of the difference of the intercepted arcs. Now, I'm going to explain what that means because it's not all that difficult, it just sounds different. Remember, the word difference means subtraction. So if I've got intercepted arcs here and here, these are the two arcs that are created by this angle. Okay, so if I call that angle 1, okay, then I get these two arcs. Let's give them some letters. Let's take letters A, B, C, and D again. Okay, so this vertex of the angle, call it point P, is in the exterior of your circle. So this arc, or this angle measure, has these two intercepted arcs, and its measure is half of the difference of those two. Very much like above, where we added the two arcs and took half of that. When the vertex is outside, we're going to subtract the two arcs, and we always do the larger arc minus the smaller arc. We will never get a negative angle measure here. So in this case, the measure of angle 1 is equal to half of arc, the measure of arc AB minus the measure of arc CD. All right, and so we're going to practice a little bit more of this in class. I've got some more examples for us to do, but the basic idea is pretty much the same. That if we want to talk about an angle having to do with the circle, it's related to half of the arcs most of the time, either half of the sum of the arcs, so we add them and divide by 2, or it's half the difference of the arcs if it's outside. We're kind of just inverting that process. Okay, or if it's just half of the arc, if it's an inscribed angle, where the angle is on the circle somewhere. Okay? All right? And then the one exception is that when the vertex is at the center of the circle, it's just half of the one arc. And we're going to look at, we're going to look at more of the relationship between the central angles and these other angles inside the circle a little bit in class, but for the most part you should have these down. So I'm going to kind of go through and just position these, so if you need to pause the video to recopy any of this down, you can. For central angle, you need to have this copied down. Make sure you underline central angle, meaning it's at the center. Okay. And then for the when the angle is in the circle, the vertex is in the circle, make sure you have that copied down. This word is intercepted. We'll talk more about that in class also. Okay. And then when the vertex is on the circle, and finally when the vertex is outside the circle. So make sure you have those copied down, and we will be ready to go with more examples in class.